Engineering is how we turn abstract scientific theory into the physical, built world. But if you're trying to choose a career or just understand how things work, the landscape is massive. Here is every major engineering discipline explained. First, mechanical engineering. This is the study of objects and systems in motion. If it has moving parts, a mechanical engineer built it, from your car's transmission to industrial robotics and roller coasters. The main bottleneck is physical prototyping is slow, material-dependent, and incredibly expensive to iterate. Next is civil engineering. They design, construct, and maintain the physical built environment. They are responsible for the infrastructure keeping society functional: bridges, dams, clean water systems, and structural skyscrapers. The downside is extreme regulatory scrutiny and zero margin for error. A single math mistake costs human lives. Third is electrical engineering. This deals with the study and application of electricity, electronics, and magnetism. They develop everything from massive power grids to the microscopic circuits inside your smartphone. The bottleneck is that you are managing invisible forces. Debugging faulty hardware systems is notoriously difficult without complex telemetry tools. Closing out the traditional pillars is chemical engineering. This branch scales up laboratory chemistry to mass manufacture products. They transform raw materials into usable goods like plastics, refined petroleum, and pharmaceuticals. The risk factor is high. Operations deal with volatile, high-pressure, toxic, or highly combustible materials, leaving a heavy environmental footprint. Moving into specialized fields, aerospace engineering focuses on atmospheric flight and space exploration. They design commercial aircraft, satellites, and deep space rovers. The obstacle is astronomical budgets and brutal physics constraints. Everything must be structurally flawless while remaining as lightweight as possible. Computer and software engineering bridges the gap between hardware interfaces and digital applications. They design operating systems, network architectures, and the complex AI algorithms driving modern tech. The industry suffers from rapid obsolescence. Code frameworks and hardware standards change so fast that your knowledge can expire in just a few years. Biomedical engineering integrates engineering principles with biological sciences. They design life-saving healthcare technology, including artificial organs, pacemakers, advanced prosthetics, and MRI machines. They face incredibly long development cycles due to strict clinical trials and the immense challenge of human biological compatibility. Finally, environmental engineering develops technical solutions to protect public health and restore ecosystems. They build massive water purification facilities, air pollution controls, and hazardous waste management systems. From a business standpoint, corporations often view environmental engineering as a compliance cost rather than a profit driver, making funding highly dependent on government regulations. Every piece of technology around you relies on a combination of these blueprints. Comment below which discipline you want us to tear down next. Subscribe to Breakdown Engine for more structural breakdowns. See you in the next schematic.